So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own Mascota this side. And today we will be solving another POTD. Okay, so what does the today's problem say? Today's problem is buy and sell a share at most twice. Let us look at the problem. So the problem states that you have been given an array which is representing price of stocks, right? So this is the price of stock on day 0 for day 1, day 2, day 3, day 4, day 5. Okay, you have to maximize your profit, right, by buying and selling a stock at most twice, two times, at most two times. Okay, now the condition given to us is that you can sell a stock only if you have already bought it, already bought it. And if you have already bought a stock, if you have already bought a stock, then what do? Then the only option for you is to sell. Like you cannot buy two stocks one after another. That is you cannot buy 10 and without selling the 10 once, you cannot buy 22 again, right? First you will have to sell 10, then you will have to buy 22. That is only the provision allowed to you. All right. So for in this case, what should be the maximum answer that is possible? Right? You can buy at 10, sell at 75, then buy at 65, then sell at 80, right? What is the profit then? If you buy at 10, sell at 75, and then buy at 65, then sell at 80. What is the profit? It will be 65 plus 15, which is equals to 80, right? Another option is you buy at 22, sell at 25, 65, 80, which will be a less one because 22 is actually greater than 10, right? Another option is if I buy at 10, sell it at 22. If I buy here, sell here, and then I buy at 5, that is here, and last sell at 80. What is the profit now? It is 12 plus 75, which is equals to 87, I guess. Yeah. So I have checked it thoroughly before making starting the video that it is the maximum answer available to us, right? It is the maximum answer for this array. Now the homework for you is to check all the subarrays, like all the possible combinations, and then tell me is it the correct one, right? Now, when you will be doing all the possible combinations, you will be getting a particular algorithm in mind. What is that algorithm? That you have to explore all the cases. You have to you have to explore all the cases. And the previous videos also I have told you that whenever it comes at explore all the cases, that means you have to use recursion, right? And when drawing the recursion subtree, if you find overlapping subcases, in that case, make it a DP problem. That is apply memoization and change it to dynamic programming problem, right? This is the flow. Okay. So we have 10, 22, 5, 75, 65, 80, correct? What we will be doing is, it is given to us that to sell a stock, we have to buy it first. So first operation will be buying, right? We will start from zeroth index. Right? Now we have to buy. So let us say we have to buy. Okay. If we have to buy and our maximum limit is 2 because you have not bought any stock, the transaction is not completed, any transaction is not completed, right? So we have to complete two transactions. We can complete two transactions right now. Okay, let me write the array here. Yeah, so this is my array, right? I'm currently standing at 0th position. This is 0, 1, 2, 3, 4, 5, correct? And I have to buy. Two options are there with me. Either I buy this stock at 10 rupees, or I skip it, right? I don't buy. I go to the next index, right? So first is to take it, second one is to reject it. If I take it, then I'm moving to the first index, correct? Now, if I have 10 in my hand, I will have to subtract 10 because I have to give 10 rupees to buy 10, right? And then I will have to change my mode to sell because if I bought something, then I will have to sell it first. So change it to sell. But have I completed any transaction right now? Like you can say that we have completed half the transaction, but I'm saying that let's treat in whole numbers only. So when I will complete it, I will say the transaction is completed only when I sell it. Okay. So it's S and it will remain 2 only, not completed. Another sub case is if we not take it, it will go 1 because I have not bought anything, it will remain same, that is B, and two transactions, right? And nothing minus because I have not done anything here. I am on the next index. So let us solve the left subtree first. So 1s2. Okay. So I'm standing here. The choice with me is to sell it or to skip it, right? So to sell it or to skip it. Now, if I will be selling it, then I will have to add 22 because I'm getting rupees 22 in my hand, and I will move to the index 2. Now, if I've sold it, it will change to B again because I have to buy again. And if I've solved it, if I've solved it, then a transaction is reduced, so it will change to 1. Correct? Are we on the same page? Correct. If I've not solved it, then it will change to only the index will increase 2s2. Right. I'm standing on 2. I have buy in hand. Again, two options. Either I buy it or I skip it. If I buy it, I will have to decrement minus 5 because second index is 5. Okay. Then 3 as 1. Or if I skip it, then 3b1. Right. Okay. After that, again, selling two options. Sell it or don't sell it. Then third index is 75. So increment 75 if you sell it and move to next index. That is 4b0 and otherwise 4s1. Now whenever you encounter 0, that means the transactions are completed. And if the transactions are completed, no matter of going further, like if you're standing here and you see that the transactions are completed here only, in this sub array only, why will you bother to see the next sub cases? You will only return 0 in this case, right? Return 0 because this doesn't return you anything, right? Return 0. So now 0 plus 75 gives me 75. Okay. Now this sub case has to be done up till now also. So 4, 5, 1. So I'm standing at 4 and sorry 4 as 1. I'm standing at 4 and I have to sell. Again, two cases. I can either sell, I cannot sell. If I'm selling it, I will move to 5 with B option and 0. Again 0 encountered. And if I was selling, then fourth index was 65, right? So it will be 65 plus. Otherwise, it is 5 as 1, right? And 0 encountered, so it will return in 0. 0 plus 65. This is 65 here, right? And 5 as 1. Okay, 5 as 1. So I'm standing at 80. The only option with me is to sell or to skip. So to sell or to skip. If I'm selling, I will be incrementing 80 rupees in my fund, otherwise not. So if I'm skipping it, it is 6 as 1 and it is 5, what do we say? Oh, sorry, 6b0. As you encounter 0, return 0. 0 plus 80 gives me 80. Left is returning 80 and right is returning 6. 6 index is not present. It is out of bounds. That means you cannot sell. That means it will also return 0. No transaction possible right now. So it is returning 80, it is returning 0, which is maximum 80. So it will be returning 80. Now 65 is the left, 80 is the right, which will we have to return the maximum. So it will be returning 80. 75 and 80, which is the maximum 80. So it will be returning 80. Okay. 3b1 is the option now. 3b1. So we are standing at 3, we have to buy, right? And we have one transaction left. Okay. So 3b1 has again got two options to buy or to skip. If I buy it, I will move to 4 with selling option and one transaction in hand. And if I don't buy, I will move to 4 with buying option with one transaction in hand. All right. 4s1. Now you can see that 4s1 is already solved. It is running 80. I will also return 80. Right. But 4b1 is not solved. So I will have to solve 4b1. Right. So 4b1 again has two options. What are the options? Uh, For also 3b1 will be minus, right? 3b1 I will have to minus, right? 3b1 I will have to minus 75 because I have bought. So it will be turning 5 here. Left is running 5. Talking about 4b1, 4b1 two options either to buy it or to sell it, or either to buy it or to skip it, right? So this will be the going of the subtree. This will be the going of the subtree. Subtree. I'm not enlarging it because it will become very lengthy, and I hope you are understanding my point of view. The homework for you is to enlarge the whole subtree, because that will make you understand what is actually happening. Okay, so we also visualize that overlapping subcase was also there, right? So we have to do the recursion and then change it to DP for better optimization. Correct. Okay, so what is the recursion pseudocode then? The recursion pseudocode will be, suppose I'm implementing a function solve, it will take my prices, it will take the number of transactions left, that is, let us say left, starting with 2. It will be given 2 in the starting. My mode, that is either B or S, right? Otherwise, and my index, which on which index I'm standing, right? So, what are the base cases? If left equals to 0, that is, I have used all my transactions. In that case, return 0. Otherwise, if my index is greater than equals to n, that is, it has passed the limits of the stock days, in that case also return 0, right? These are the base cases we discussed in the subtree also. Otherwise, if b, that is, if I have to buy, in that case return, what do I have to return max of, either to buy it, then in that case decrement the price of int, plus go for the next option, that is solve for int plus 1. Now mode will change to selling, and transactions will be remaining same, right? Other option for max will be to skip it, that is solve, go to int plus 1 with the same mode, that is b, and the left is also same, right? Otherwise, else, if s, that is, it is in the selling mode, in that case return max of. Now we have to increment the price of that index, right? Price of int plus solve, and because you have solved it, then it will go to the next index with the buying mode, and because you have solved it, we have used one transaction, so left minus 1. And the next option for selling is to skip it, that is solve int plus 1 with selling option and the same number of transactions, right? So this is my pseudocode, right? Now I will not tell you how to implement DP into it, because I think you are well versed in DP, right? You will have to just use a DP array. I'm giving you a 5-minute break. Pause the video and check what will be the dimensions of DP array. Okay. So I hope you have paused the video and tried on yourself. So whenever I do a DP question to you, I to tell you to see what things are changing in the function. So in this function, my left is changing, my mode is changing, and my index is changing, right? So it will be a 3D array. It will be a three-dimensional array. Okay. Now, what are the dimensions of this? Let us say these are the dimensions. N is the size of the array, right? So my int is going from 0 up till n minus 1, because for n I am returning 0. So it will be of n. My mode is only 2, so change it to 2. My left can be 0, 1, 2. So change it to 3, because 3 will be inculcating all three indexes 0, 1, and 2. Right? So this will be the size of the DP array, and then you can easily inculcate if DP equals to DP of what do we say, index with mode with left is not equals to minus 1. In that case, return this value only. Otherwise, whenever you are returning, change to DP index mode and left. Update your DP array like that. It will be done. All right. So I also tried doing the same, right? And when I wrote the code, I was able to see that my code was running fine for all the test cases except for the last one, and on the last one it was giving my segmentation fault. I tried using seeing the YouTubers video also, which I inspire a lot, and I was not able to find a correct solution, because the solution they were writing was also the same. This was the same code that they wrote, but it is not running fine on GFG. It was running fine on lead code. It was running fine on coding ninjas, but I don't know why GFG is not passing the test case. So I thought of doing it in another fashion. So we will be discussing another way of doing the same problem. Okay, and this problem is this solution is way more efficient. So we will be discussing an efficient approach, that is say optimized approach. So let me write the array again. My array was 10, 22, 5, 75, 65, 80. Correct? This was my array. Now, if I told you that do the same problem, and if you don't know about recursion, you don't know about TP, a sensible student will say that if I look at the brute force approach for this question, it would look something like I will have to choose two subarrays. I will have to choose I will have to choose I such that 0 to I and then I plus 1 to n minus 1. I will have to do two transactions, one from this, one in this range, another in this range. And I will have to do transactions such that the sum is maximized. Correct? Am I speaking correct? Yes. That suppose what was our answer? Our answer was to buy at 10, sell at 22, buy at 5, sell at 80. So you are able to see that my array is actually divided into two partitions. Buy at 10, sell at 22, buy at 5, sell at 80, right? Two partitions there are. So my approach will say that move I for I going from 0 up till n minus 1. And what I will do is in left subarray, I will find maximum, I will find maximum profit. In right subarray, it is in right subarray, I will find maximum profit and then add them up. Left plus right is my answer. I will have to update. Okay. Now you might be asking why, how will I find maximum profit? For that, let us look at the problem. Let us take the same example: 10, 22, 5, 75, 65, 80. Let us assume the question says to find the maximum, what do we say? The maximum profit in one transaction. In one transaction. This is for one transaction, right? How will you solve? You will say the maximum up till this index is 80. Then 80 and 65, it will be also be 80. 80 and 75 are also 80. 80 and 5, 80. 80 and 22, 80. 80 and 10, 80. Right? So if I see the maximum from right to left and keep incrementing, then I will see that 80 is the maximum. I am keeping the count of maximum on the right side. Right? Because I have to sell in the right. I have to buy at left, sell at right. Correct? So if I'm traversing from here, I will see the maximum here is 80. Maximum in the right subarray is 80, right? 80, 80, 80, 80, 80. Okay. What is the maximum profit I can get? The maximum profit is the difference between these two. So 80 minus 80 will give me 0. 80 minus 65 will give me 15. 80 minus 75 will give me 5. 80 minus 5 will give me 75. 80 minus 22 will give me 8 and 58, right? 80 minus 10 will give me 70, right? Now the maximum among these is 75. So I will say this is my maximum profit. You can also check if I buy a stock at 5 and sell it at 80, then this will be my maximum profit, right? So this is my way to find the answer for one transaction, right? So I will use this formula of one transaction to check in the left subarray, in the right subarray, and I will maximize my profit. What is the time complexity for the above approach? So this will be moving n times, okay? This will be taking n operations. This will be taking n operations. So n into 2n, that is 2n square, which will go to O of n square, right? This is also a good approach. I will not say that it is a very bad approach. You can tell it to the interviewer, but can you optimize it? So the thing is, can you optimize it? Can you optimize it? The answer to yes is that is yes. But to listen to that answer, you will have to subscribe first and like the video, because it has taken a lot of effort, particularly in this question, to judge what is actually happening. Because this approach was not able to, I was also not able to explore this approach in previous few months, right? This just clicked when I saw this POTT today. So what I'm doing is I have got 10 with 22, then 5, then 75, then 65, then 80, right? I will make a profit array. I will make a profit array, an auxiliary array of same length, right? Of same length, right? Just remember the approach, this approach. We will be implementing it in a less time complexity. Okay. So this is my auxiliary array. The thing I was doing here, I will do the same thing here. What I will do is, I will this let us name this as temp, right? So what is my temp of I representing? This is about the first traversal. I will do the traversal two times. For the first traversal, my temp I will be representing maximum profit from I to n minus 1. Okay, in one transaction. In one transaction. Okay. So 80 will be 0. 80 minus 80 will be 0. But maximum with me is 80 right now. Maxi, I will update a maxi here. Maxi is equals to 80. Okay. I move to 65. I see maxi is 80 right now. 80 and 65 will give me 80 only. So my profit will be either this, either 0, or either 0 or maximum of 0 plus 0 comma 80 minus 65. So you will see 80 minus 65 is 15. That is, if I buy at 65 and sell it at 80, it will give me 15. But the profit at 80 is 0. So it will be 15, right? 0 comma 15 maximum it was. Okay. I go to 75, I still see that 80 is maximum, right? Now the value here will tell me what is the maximum profit I can get from this subarray till this subarray. Okay, I don't have to subtract this with the maximum value. I have to check what is the maximum possible in this array. It will see 80 minus 75 will give me 5, but 15 is already existing, so it will take 15. Okay, I move to 5. I see 80 minus 5 will give me 75. Is it the maximum? Yes, is the maximum. So take it as 75 only. I go to 22. I see 80 minus 22 will give me 58. But 75 is already the maximum. 75 here. Okay. I go to 10. I see 80 minus 70 will give me 70. But 75 already present. So 75. Okay. I will get this array in O of n time complexity. Okay. Let's see what did we do. Our pseudocode for the first traversal was for I equals to n minus 2 going up till 0. Okay, we will keep a maxi as ARR of n minus 1. Okay, for I equals to n minus 2 to 0, what I will do is my maxi will be updated first. My maxi equals to max of maxi and ARR of I. Okay, and after that, my temp I will be equals to sorry, max of temp of I plus 1 comma um, maxi minus temp of I. Sorry, minus price of I. Okay, so in this pseudocode for the first traversal, I will get this array, this subarray. You can dry run on it on your own. See, I can also do the dry run for you, but I think that is useless if you don't try it on yourself. You will not get any knowledge. Okay, so I'm not doing a dry run. I'm just providing the pseudocode and what I'm actually doing, all the algorithms, right? You should be able to do the coding on yourselves. Okay, so my first traversal is done. I have got 75, 75, 75, 15, 15, 0. Let us see what once again what is this representing. This is representing, this value is representing maximum answer I can get in this subarray, right? And what was our need? We wanted, suppose this is my array and this is where I'm splitting. I wanted this maximum and this maximum, and I will have to add them up and then I return the answer, right? This was the original brute force approach. So if somehow for this index only I can get this value maximum, isn't my problem solved? Yes, the second traversal will be doing the same thing. For the second traversal, what we will do is, so our array was 75, 75, 75, 15, 15, 0, and this was 5, 22. uh, Sorry, it was 10, 22, 5 65, sorry, 575, 65, 80. Right, this was my price array, this is my temp array. I will have to update temp array only. I can do the things on other also, but I am using the same space, right? So this is my array. What I will be doing is, now I will make temp pi. This is for second traversal. Now after this traversal, my temp pi will be storing maximum, uh, what do we say, maximum sum of two transactions. Two transactions if splitting point is I. If splitting point is I. Okay. What I will do is, I'm standing at 0th index, right? I'm standing here, 0th index. I will see the minimum here is 10. I will in the first case, I was keeping a count of maximum. Now we'll keep a count of minimum. So my minimum is 10, right? Now I will go here. I will say a transaction possible is 22 minus 10, right? And the sum of this. So 22 minus 10 plus 75. Can be the maximum. So 22 minus 10 plus 75. This can be the sum in the this subarray plus this subarray. Now, if it is greater than this value, then increment it. So I will see 22 minus 10 plus 75 will give me 87. I will say it is greater than 75, so I will change it to 87. Okay, minimum is still 10. I go to 5. I see minimum is 5 now because 5 is less than 10, so it will change to 5. I see 5 minus 5 is 0. 5 minus 5 is 0. But if I do 5 minus 5 plus, what is the value here? 75. It will give me 75. Is 75 greater than 87? No. Then change it to 87 only. Okay, boss, done. Third test case, I go here at 75. I see the minimum is 5. So I say 75 minus 5 plus 15. What is the value? It gives me 70 plus 15 gives me 85. Is it greater than 87? No. Change it to 87 then. Okay, sir. I go here at 65. I say, what is the minimum? 5. So 65 minus 5. And what is the value? 15. What is the value? 60 plus 15, which gives me 75. Right? It gives me 75. Is it greater than 87? No. Change it to 87 then. No problem. I go to 80. Now 80 minus 5 plus 0 is the value at 80. Right? What is the value? 80 minus 5 plus 0 gives me 75. Is it greater than 87? No. Change it to 87 also. Okay, change it to 87. I see the maximum value obtained to me after two transactions. After two transactions is 87. And that is the answer I need. So it will be my final answer. What is the pseudocode for second traversal? Pseudocode for second traversal is, I know the video is long today, but please believe me, the question was also important. This question is asked in Amazon, Google, and such great companies. So second traversal will say, for I going from 1, not from 0, up till n minus 1. My mini is equals to ARR 0 right now. Right? What I will do is, I will say temp of I. First I will have to update my mini also. Okay, mini is equals to min of my already existing mini with ARR of I. Right? My temp of I will be equals to maximum of temp of I minus 1, that is already existing profit, or price, that is ARR of I, sorry, ARR of I minus mini, that is the profit from what do we say, left sub array, plus what was existing at ARRI. Oh, sorry, what was existing at temp of that index. Okay, update your temp, and to return your answer, you will be always return temp of n minus 1. This will be your final answer. Time complexity is O of n. Why? Because we are doing two traversals, O of n plus O of n. Space complexity, again O of n. Why? Because we are just using a temp array of O of n. This code is working fine in GFG. Thank God it is working fine. The code we discussed about the dynamic programming was also fine, but I don't know why it is giving segmentation fault, so I was not able to fix it. That's why I devised this approach. If you like it, please give it a thumbs up, and please, if you're new here, please subscribe to my channel. So we will move on to the coding area and do the code uh, efficiently. What I will do is I will first take my size, price dot size. Let me zoom in a little. Yes, in price dot size. Okay, what was the second thing? We have to create a vector of temp, name it as n, and initialize it with 0, right? Our first traversal was from right to left, was from right to left, correct? So what I will do is I will update my maxi first. Maxi is price of n minus 1, right? Now for int I going from n minus 2, I greater than equals to 0, I minus minus. What I will do is my temp of first I will have to update my maxi also, right? So my maxi is equals to max of maxi comma price of I, right? And my temp I will be max of temp of I plus 1 with what was the operation? It was maxi minus price of I, because I will be selling at maxi and buying at I. Okay, comes the time for second traversal. Second traversal, what was the second traversal? It was from right or left to right, right from left to right, and we have to count for mini. So my mini is equals to price of 0th, right? And I will start from first index. So for int I equals to 1, I less than n, I plus plus. Sorry. What I will do is I will update my mini. Mini equals to min of uh, price of I and my already existing mini, right? And then my temp of I will become max of my temp of I minus 1, comma, if I buy it at this index, price of I minus mini plus temp of I, right? And at last, as said, return temp of n minus 1. Hope you have got the problem. Let's try to compile and run it. Hope it works. Fingers are crossed. And it is running fine. Let's try to submit also. In the meantime, if you are new here, please subscribe to my channel because it gives me a lot of motivation. And that's all from my side. Let us wait for the results. It is taking a too much long time. I think many people are submitting right now. Uh, yeah, it has been worked correctly. So you can see a 70 days current streak. Thank you for all your love, and do give a like. And if you have any doubts or you want to appreciate or you want to say anything to me, please use the comment section. And that's all for today. We'll meet tomorrow. Till then, keep coding, stay safe. Thank you. Have a nice day.